Hello students, this is Dr. Faizan Mirza. I am discussing Spearman's rank correlation coefficient with you. When we are discussing Spearman correlation coefficient, let's recall the Spearman rank correlation is actually applied when you draw a scatter plot and the scatter plot doesn't show you that whether a linear correlation exists or not. But you think that yes, probably a correlation may exist. So in that case, you just rank the values of your data and then you calculate the value of RS and you compare the value of RS for the critical values at probability level of 0.05. So how do we do that? This is the Spearman rank correlation coefficient calculation. For example, a coordinate was placed 10 times. The number of species R and the number of species S were just counted. In this case, what would be the null hypothesis? If I ask you, the null hypothesis would be that there is no significant correlation between number of species R and species S. We'll always use the statement. We'll begin the statement with there is no significant. And since this is the statement of correlation, so we'll state that there is no significant correlation between number of species S and number of species R. What's the first thing that we'll do? We'll just make a scatter plot. We'll make a scatter plot taking species S here, species R. This can be taken otherwise as well because the variables are not dependent on one another. This is correlation. So I plot a scatter plot. And my scatter plot actually tells me that I have coordinate 24, 38, 52, 8, 22 and so on and so forth. I'll just place them here. And I can see that yes, positive linear correlation is expected. I'm making judgment by I. And if the judgment is by I, it means that yes, the correlation might just exist, but I'm not very sure how strong is the correlation or whether it's present or not. So what I'll do, I'll just start to rank the data. So I have my quadrates here, so I'll just make another table. Again, this is 10 quadrates, the same row which is mentioned here. Number of species R's are given here, number of species S are given here. So I just copy R's and S the numbers in the relative columns. Then I start to rank the species. Now how the species are ranked? The species are ranked by giving the first rank to the smallest value. For example, if I look at this column, the smallest value is 1. So I'll give 1 rank to this value here. My second value, which is 8, is larger, so I'll just give the rank 2 here. Then my rank 13 is much larger, I give that rank 3. Then 20 is way more larger, I give it rank 4, and so on and so forth. I have to give a total of 10 ranks here because these are 10 quadrates which are placed, so I have to rank these 10 values in rank from 1 to 10. Now come to species. Again, I have to rank these values in the range of 1 to 10. I'll start by using the smallest value with the largest rank, so in the ascending order. You can follow the descending order as well, but the same order should be used in both cases. So as far as in this column, 4 is the smallest value, so I'll give the rank of 1 to the smallest value, 4. Then if I move from here, 5 is the larger value, then I give the rank 2. And after that, for instance, if this is 6 here, so I give it rank 3 and so on and so forth. So I have my columns ready, the ranks are here, and I'll just move on to the next column. Now what's next in the next table is here. Again, the same coordinates are listed 1 till 10. The rank of both the species are now mentioned here. Rank for species R that I completed, rank for species S that I have made. So both the ranks columns are just copied from here. At times they give a same table, you just rank it and you just calculate it there only. What you do here? After using the ranks, the data has been ranked. The next thing is that we calculate the difference in the rank. Difference in the rank is actually capital D, and then we'll use capital D squared. Now do not confuse this D with diversity index, because diversity index also is represented by D, but that's a different case altogether. This D here is the difference in the rank. Difference in the rank means you will just subtract 6 from 7. So 7 minus 6, your answer is 1, you just square it. Then it's 2, this 1 minus 2, the answer is minus 1, you square it, and so on and so forth. You complete both the columns. Once the last column has been completed, I'll calculate summation D square. So I'll sum up the last column. This comes out to be 12. This is the formula for the Spearman rank correlation. So RS is equals to 1 minus 6 multiplied by summation D squared upon n cube minus n. So you don't need to learn the formula, but you need to know how to handle the formula. So 6 is to multiply by summation D squared. My answer summation D squared comes out to be 12. So I place 12 here. So I have to multiply 6 and 12. So 6 and 12 getting multiplied here. Divide by n cube minus n. N stands for the number of times the observation was taken. So 10 quadrates were placed. So this is 10 cube. So I place 10 cube here, minus 10 n again. So it's minus 10. So my variables, all I have just added here, substituted the values here. I'll just calculate the answer, and the answer should be calculated for 2 decimal places, and the answer comes out to be 0.93 in this case. If the answer comes out to be 0.93, I told you that in this case of Spearman rank correlation coefficient, we calculate the RS value and we compare it with the probability of 0.05. So the probability of 0.05 level critical values are given to me. These are the critical values here. My n was 10. The value of n was 10. So I'll just go straight in the column of 10 and I'll look for the critical value here. The critical value is given 0.65. Now I know that critical value is 0.65, the RS value is 0.93. I need to compare the two values. This is the same thing that we do in chi-square test as well. The same thing we do in t-test as well. We compare our value, the calculated statistical value, with the critical value. In this case, we know that the RS value 0.93 is greater than the critical value 0.65. If the calculated value is greater than the critical value, then the difference, or you can see the correlation, not the difference, the correlation is actually significant, because there is a significant correlation. It's not insignificant. If the value of RS was smaller than the critical value, then the correlation would have been insignificant. So the conclusion will be that since the RS value is greater than the critical value, you can quote both values here. The correlation between S and R is significant, and the null hypothesis is rejected, because the null hypothesis stated that there is no significant correlation between number of species R and the number of species S. You can just work out this another worked example for you. I'm just giving you this thing here. This coordinate was placed 11 times, so this will be your value of n. You can just n cube will be 11 cube minus n, which will be 11. 6 multiplied by summation d squared. You need to find out d square here. So what I will do, these are the C vulgaris, C V martilis. We know we can state the null hypothesis that there is no, we are calculating the percentage cover here. So the null hypothesis will be there is no significant correlation between the percentage cover of C vulgaris and V martilis. We can state the null hypothesis. That's the thing that we'll do is we'll just rank these values, we'll rank these data, and when we rank them, the ranks will be mentioned in this column, in this table. You can just fill up these here, and the difference in the rank can be calculated by subtracting 9 by 8 and then squaring the value. This will be d square. You will sum up the last column, and the sum of this last column will be placed here. You calculate the value, and you just see whether the difference, whether whether the correlation is significant or not. This is how this is my worked example. This is the working of the ranking here. So I have ranked these here. You can see that the smallest value is given the smaller rank. For example, 3 was the smallest one, I gave it rank 1. 5 was larger, I gave it rank 2. 9 was larger, I gave it rank 3. Then the next value was 10, I gave it rank 4. I have to give 11 ranks here. So all these 11 values have to give 11 ranks in ascending order. But when I come to 15, I have two 15s here. So both these 15s I have used up rank 1, 2, 3 and 4. Both these 15 have the same rank. So one of them is 5th and one of them is 6th. I don't know which one is occupying which rank. So what I'll do, I'll use 5 plus 6 divided by 2, and my answer is 5.5. So I give 5.5 rank to both. This is when both the observations are occupying the same rank. So we add the available ranks here, and we just divide them by the number of observations which are occupying that rank. So in that case, it's 5.5. So 5.5 is given to both of these. Now, if 5.5 is given to both of these, this means I have used up my rank 5 and rank 6 both. I can't give rank 6 now. I have to move and give rank 7 to the next. So my value after 15 is 20. I'll give it with the rank 7 and not the rank 6, because 5th and 6th combinedly have been used up as 5.5 for 15 each here. For example, if I had 3 15s here, 15, 15, 15, so I can't give 5.5 here. Then I'll just add 5 plus 6 plus 7, because these are the 3 ranks, available ranks, 5 plus 6 and plus 7. They are occupying each of these, so I'll just divide them by 3. So 5 plus 6 plus 7 will be divided by 3, for example 6 each. Then in case, I'll just mention 6 along each of these which are having that particular rank. And the next value will not be having the 7th rank. The next value will have the rank 8. I'll omit out the rank 5, 6 and 7 altogether. This is how we work out these examples. The RS value can be calculated. You can just compute this here, and you can just see what results you are getting. Now let's suppose if the question comes that if the ecologists think that the relationship between is the result of habitat preference, that both species prefer drier soil, both of these prefer drier soil. Describe an investigation that could be carried out to test this hypothesis. What you can do, you can just mark the large area with a tape in the rectangular field. Use a random number generator to get the set of 10 coordinates. Use a quadrate, for example, of 0.25 meters squared, and record the percentage cover of both species in each quadrate. Use a brown blanket cover scale. We have already discussed all these in detail in the previous classes. We can use the soil sample. How to take out the soil sample? We use soil auger. This instrument is called soil auger. It is screwed to a certain depth to take out the soil sample. So we'll take out the soil sample using the soil auger, and this is screwed to a certain depth, to a fixed depth, and the soil sample is collected. We'll take 3 soil samples from each quadrate, and then we'll just weigh the soil sample and dry it in a desiccator. Desiccator is like a microwave oven. It's more sophisticated though. So a desiccator is used for dehydrating a sample. So we'll just drive away all the water from the soil sample. We'll calculate the soil moisture by calculating the decrease in the soil mass upon drying. How do we calculate this? The soil moisture can be calculated by decreasing the mass of the soil, like we measured it initially, and after placing it in the desiccator when all water had been evaporated. all the water had evaporated from that soil sample. We divide that by the original mass of the soil, we'll multiply it by 100. The soil moisture will be calculated. We can draw a scatter plot of percent cover and soil moisture. We can probably calculate the Spearman rank correlation correlation coefficient, and we can calculate the value of RS and compare it at the P level of 0.05. There are some precautions that you have to keep in mind. Stay with the group, avoid getting lost, wear proper clothing to prevent any accidental insect bites and so on and so forth. So that brings us to the conclusion that all these statistical calculations for this particular chapter have been completed. That's it from my side. Thank you so much.